Yay.
He's like,
And he leaves. And I do believe we're live. Hello, everybody. The first and most important question, does everybody have their cat? If you are in the possession of a cat, please raise your hand. Thank you.
Here somewhere?
Yeah. For everybody else, what are you doing? Yeah. No, ours got into a fight with next door's Tabby yesterday and has been sulking. Oh, very good. And has been sulking all day. I think he slept for about 8 hours. So.
oh no, he's in trouble.
And Garth is gone.
Yeah.
Oh, dear.
Well,
And Ryan
that's
Me. Hello, everybody.
hi. New host.
Oh, you're here, Garth.
Are we okay there? Did I just suddenly die?
That's twice, Garth. Your third time and you're out.
Yeah, that's 2020 being nasty. I should say I am on the reserve laptop at 7:30. The main Mac was stood up and was doing a 2-minute update, which last time I looked at had.
Oh no.
Oh,
okay.
Are we okay? No,
yeah.
we're back again. So hopefully it will stabilize. Yeah. So once the other laptop does its thing and shuts down, then everything should be okay. So let me just start in, and then if for any reason we suddenly die, it's over to you, Ryan. So sorry about that. Yeah. So welcome to the final bash of 2020. Yay! You know, so we managed to get one last one in. So this will be the last bash of the year, so not an awful lot of announcements. I can say, though, with my other hat on, as one of the organisers of the Belfast user group, we will be January. Yeah, so nothing like the vicarious thrill of doing an announcement on a .NET event, you know, yay, yeah. So that's the only thing I have in my head. Apart from for the next batch, yeah, which is hopefully going to be in January or February, we're thinking of things we learned from 2020, okay? So things that are you or your company learned from 2020, and that could be how your firm improved or how you improved or coped with the different circumstances and so on, and especially looking for graduates, junior developers, people like that, because we know that they've had an especially hard time. Yeah. So if you have a story that you want to tell in that regard, please let us know. So that's the announcements out of the way. Except to say, continuing thanks to Ryan and Zara, and it may be a special thanks to Ryan by the end of this episode. We'll see how it goes. Yeah. But for our first talk, if I can call on Scott. So Ryan, if you can vanish everybody apart from Scott, and sir, if you can make a start in.
Hello. Hey, friends. I'm Scott Hanselman, and I am the first of a day full of lovely stuff here. Actually, several hours of wonderful things here at .NET Bash with our friends. Looks like we've got topics coming up here from, let me see, I've got multiple monitors here, and I put all of my different topics and names down on the things that I'm going to talk about. We've got Andrea coming up after me, and then Alan, and then Laura. We're going to hear about .NET. I'm going to talk about WSL and a little bit of .NET. After me, Andrea will talk about the history of .NET. Then Alan will take a look at .NET into serverless and in the cloud and in how .NET works in Azure Functions. And then Laura will talk about her graduate project. So we're going to have a bunch of really great topics. And I would encourage folks to comment in YouTube where I'm watching. And we're also going to be looking in the chat here in StreamYard. So if anyone has anything that they want to say, we're going to make sure that we listen and answer questions. So yes, thank you for joining us. I see someone already saw our tweet and said that they would come by and check it out. Now, this is not YouTube. This is live. This is .NET Bash, and it's absolutely live. So all the talks are going to be right here, which means you can ask questions of the real people. So I'll do a talk, and then everyone else will do a talk, and they will answer your questions live, which is lovely. So this is my computer right here. And what I'm going to do is I'm going to show you a few things about the terminal on Windows, and I'll talk about WSL, and I'll talk about .NET, and then Ryan or whoever will tell me to shut up because I'm talking too much. Okay, I'm going to go and type in cmd.exe, cmd. This is the command prompt. And this is going to start up this black window here, and it says Microsoft Windows. We've all seen this before. This is the command prompt in Windows. It's kind of DOS, but not DOS, and it notoriously sucks. Basically, everything that can be bad about a terminal is this. It has mediocre font rendering. It's very slow. It's incredibly old. It doesn't do what you want when it comes to copy-paste. And if you click up here in the upper left-hand corner, you click on what's called the System menu, and you click Properties, you will see this very old-looking dialog box. It has things about height and screen buffer and all this kind of stuff, and it has the font that you want to pick, and it's just generally dodgy looking. There's also some very questionable UI and UX choices here. I'm not sure who made this or what the spacing is. It's just kind of awful. Here's the thing, though. I'm going to bring up Notepad because I'm going to explain the thing. This is super interesting. What is this? What do we call this, right? When you are a Windows person, or if you're a Mac person who's come over to Windows, you might hear this called the command prompt, right? But if you talk to folks who are using Macs, they might call it the terminal, or terminal app, or terminal.app. But you'll hear the term terminal, you'll hear the term shell, you'll hear command prompt, and you'll hear console. And these three words here, terminal, shell, and console, are all interchanged. They are used inaccurately. Someone might say, hey, can you open a terminal? Could you quickly just open a console and go to the command line? Could you bring up a shell? There are specific definitions to these things. So what is it that drew the pixels that is different from the thing that is accepting my keystrokes? And if I type dir for directory, it outputs the dir. That was a string, okay? It is the shell that does the text stuff. Shells don't draw on the screen. Shells deal with strings and commands. Okay? And then there's the prompt. What is the prompt? This is a little bit more esoteric, a little bit more detailed. The prompt is actually when you're sitting right here, and look at that, it's flashing. The prompt is that moment where you're being asked for input, okay? Now, terminal means the end of something, right? A terminal is at the end of something. And I've actually written a blog post about this. So if you go out there on the internet and you go and Google with Bing, for Hanselman prompt console terminal, or terminal and console, you notice that I don't even bother typing correctly because I just figure that the search engine will figure it out for me. The terminal is the thing at the end of the connection, right? It's the terminating piece of the connection. And this is right here, a TTY. This is a teletypewriter. And this was what we would type on before we had monitors, before we had consoles. When consoles showed up, they looked like this. And you had to ask yourself, where did all this come from? Is that inside the computer, or did that come from some refrigerator in another room somewhere, and that refrigerator did all of the thinking and then sent its information over here? This could be a web browser and a cloud server, but in this case, it was a dumb terminal, or inside of a console, and a mainframe, okay? So there is an important thing for us to remember, that there are different responsibilities of what's happening here. So the thing that painted DOS is old, and it sucks, and it's in Windows. Now, let's start up PowerShell, which is a different shell. Fortunately, it has the name shell in it. So I'm going to open up Windows PowerShell. Okay, looks different, different color. Everyone knows it has different look and feel. If I click on the system menu and I hit properties, look at that. That's weird. If that's the command prompt and that's PowerShell, who owns this dialog? Who made this dialog box? What's that about? I feel like Steinfeld of programming right now. What's the deal? with the command prompt. What's that about? Okay. Folks in the chat there are talking about this. This is a great point that you can type, go to the start menu and just type CMD and hit enter. It pops up really quickly. I just typed in PowerShell. Now I could type in bash, which is part of the Windows subsystem for Linux that I'm going to talk about in a moment. And I'll get a different box and I'll get, look at this, I hit properties. So hang on here. DOS, PowerShell, Ubuntu, actual Linux, and the same dialog box. So that really showcases something interesting. Someone in the chat here is concerned, said, what is that? My goodness, what is that? Well, this dialog box is owned by the console host. The console host is the thing that is responsible for painting the strings that are coming back from these various shells. Now, Windows has maybe more shells than any other environment, while on Linux, of course, you can do ZSH and fish and bash and ash and things like that. The shells on Windows are very diverse and very varied. I can type in at the command line now, git bash, which comes with git, and people will look at this and they'll say, well, this lets me run Linux, right? Because git bash gives you a bash-like environment. But look at this box here. This looks a little different. If I click here and I go looking for properties, I don't find it. I find options instead. This is someone else's console app. This is, in fact, min TTY. Remember the TTY, that teletypewriter. TTY is the thing that is talking to the strings. And when we go and SSH into another machine, we're sending strings across the wire. Someone did not like the Windows console host so much that they wrote their own. So that's interesting. Why would someone do that? Well, let's zoom in right here on this prompt in PowerShell and what's going on here. Why do these look like crap? Well, they look like crap because it's not understanding the encoding correctly. It's not getting the right font. It doesn't know what to do. There's a glyph that's missing. I could mess around with my fonts and try to fix it. But fundamentally, if I was trying to send out ANSI or ASCII or other what are called VT100 or virtual terminal codes, I'm going to get other kind of nonsense. So what we've discovered here is a few things. The console host, the thing that makes command prompts visible on Windows, sucks. Whether it's Ubuntu or DOS or PowerShell, it sucks. The one that comes with Git is called Git Bash, and it is someone else's reimagination of what a terminal should look like. So that's interesting. And what Microsoft has done to hopefully make a better environment for everyone is to make a pseudo console. Okay. Let me find the blog for that. I think it's at the command line blog. Here we go. Introducing the Windows pseudo console. Not a TTY, but a PTY, a pseudo console. And this is an infrastructure, and that goes and talks about the history of these things. And this infrastructure sets up an environment by which other people could make third-party consoles, and it corrects a number of fundamental architectural mistakes in Windows. If you have any questions and you're watching this, please do chat in the YouTube chat, because I'm watching the chat. You can see me watching the chat over here. It also tells me that you are a real person and I'm not just alone at midnight talking to myself in my room, which is always a little weird. So I'm going to type in terminal, and I see the Windows terminal right here. I also have the Windows terminal preview. That's lovely. Someone just said into the chat, "You are alone." So now I'm questioning myself, and now it's a whole mental crisis. But I will feel better since I have my Diet Coke. So here I'm going to pop up the Windows terminal. And right off the bat, you can see it's more thoughtfully designed because we've got the ability to open up different tabs. Look at this. We've got a drop down for tabs. We can open up Windows PowerShell, PowerShell Core, which is cross-platform. We can open up Ubuntu. I could open up Git Bash. I'll go ahead and zoom back out. It is nice, Alan Turpin. Thank you for saying that. I have too many. Sean Wildermuth says I have too many shells. Do I? Do I? You worry about yourself, my friend. No, just kidding. Every one of these has a reason to exist. So trust me. The point here is that it's configurable, and I appreciate that. Look at that. My friend T-Cause here in the chat is saying that they found Windows Terminal from me. I don't get any money back or anything. I don't get a referral fee, but it was a game changer, which makes me happy. So click Settings. Look at this yummy thing. This is the settings dialog box. Now soon, Motassem Alsaka is asking to share the name of the tool. This tool here is Visual Studio Code. This tool here is the Windows Terminal. The Windows Terminal, and you can find that in the Windows Store. So here I can go in and I can pick my font sizes for all defaults, or I can make custom prompts. So you see here I've added a Visual Studio developer prompt. I've added git bash manually. I can even make a custom icon. Anything that you want that returns a string and has a prompt can potentially be plugged into this, which is really exciting. In fact, I did a thing where I wanted to do a COM port and talk to a physical device. I actually put serial port COM4 on my terminal for a while, and that allowed me to talk to an Arduino. So I had a COM port, an Arduino plugged in, and I went and talked to that device, and I got a really cool thing, and I plugged it directly into the Windows terminal. So let's think about that. If we go back to our conversation here, talking about the difference between the prompt, the console that paints the picture, right? The terminal brokers the deal, and the shell, which is the text stuff. You'll notice that I can bring up git bash right here. Here's git bash. Git bash doesn't know that it's running inside of this console because it's a compatible console. Isn't that great? Soon we're going to have a graphical settings in the new year, so you should see the ability to change and massively edit your settings in the with a dialog box, which are very, 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 very nice. So notice also that I've got one of these items is boldface. That means it's my default shell. And if we go and look at one of those, you'll notice that I don't have question marks and stuff right here. I've got the correct glyphs. Those correct glyphs now look right. So then I could go over to GitHub and go to Hanselman.com. And now look at this. I've got my Git branch. I've got one new item and one changed item. So I've got some .NET code in here. See? So now I can go and say .NET build, and that's really cool. Okay, so that's going to go and build my Hanselman.com website, but I'm used to pressing Control-Shift-B. So I made a hotkey. So if I hit Control-Shift-B, watch, boop, it automatically types in .NET build. That's using PS readline. T-Cause is saying, can you set up a SQL prompt or a Mongo prompt? That is a great question. Anything that returns a string in a standard way can absolutely be set up. So yes, I think, what is it called? SQL command, SQL CMD, SQL CMD. It used to be a thing. Is it? Are you looking for it? Are you thinking about it? You want to run it? Well, it runs, but I don't know how to get in there. But yes, you can. So we could go into the settings here, and you'll notice that with mono, here's mono, which yes is still a thing. I actually run a batch file, launch command.exe, and I have a custom icon, but it returns a prompt, and that prompt then interacts successfully with the Windows terminal. Now, you see all these tabs? You might be thinking these tabs are just too much. I'm going to make this full screen. Then I'm going to hit Control-W. Control-W, 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 Control-W. Okay? Just like closing tabs, I'm going to close tabs from the browser. I'm going to close tabs in the terminal. That's because I have bound close pane with Control-W. I can go and configure this any way that makes me happy, which is pretty cool. So now I'm going to hold down Alt with this finger while clicking with the mouse. So I'm going to hold down the Alt button, and I'm going to open up a command prompt, and I'm going to open up a couple of Linuxes, and then maybe another PowerShell, and then mono. Isn't that cool? So then I could go over here and I could run htop, and I could close this, and that resizes, and I could close that, and that'll resize. And that's scrumptious. Now you might look at that and say, well, that looks like tmux or screen. In fact, that's not. What that is it's built into the terminal itself. Now, before I showed you where I was over in the Hanselman directory, and I was working on my personal source code for my website, which was here. And I typed Control-Shift-B, and that ran .NET Build, because that's what I usually work on. Over here, I'm in Ubuntu. I'm running WSL, so I'm doing my .NET work over here. So I'm going to say lsb release-a, which is a Linux command. Oops. And I'll say, let's go to Hanselman core, do a git pull, and I will do a .NET. Oops. .NET. People are watching .NET Build. So now I'm using .NET inside of Linux. So if I say .NET -- version here, and I go .NET -- version over here, a little bit different on the left there. That's because they're different, right? If I say which .NET, that one's in user bin. And over here, if I say where .NET, it's in program files. So it's important to point that out. These are a different .NET. So this is the Linux .NET. I had to install it there. But you might think this is a virtual machine. It's not. It's actually way faster. It's part of the hypervisor, but it's not firing up a giant virtual machine. In fact, if I was going to start up a entirely different Ubuntu, like Ubuntu 20.1.1002, starts up in seconds. Has full access to everything. But then if I close it down, it'll eventually go away, and I'll reclaim that memory. So that's pretty exciting. Folks in the chat are talking about, can you have remote SSH nodes? You can manually put them in there. You could also make a prompt where you could click and then say, well, which of the things you want to SSH into, and then say go, and then you could SSH into it from there. There's talk about maybe this flying out into another menu. It is very, very, very configurable, so you can do lots and lots of fun stuff. Now, we talked a little bit about how the difference between a shell, a terminal, and a console, and I mentioned a prompt. There are prompts, and Starship is one of the lovely prompts that you should check out if you search for Starship prompt. It's a cross-shell prompt. So it's a prompt for any shell. This is significant. That means you can use it on any operating system, and it lets you have a shell that'll describe what you're currently working on. So, for example, you might be working on .NET or Rust and then move to another folder and be working on something else, and that's okay. Mick Walker is asking the question that the sessions are running under the identity of the parent process. Could you run a session under a specified identity? You would have to do that kind of work using the start command or the run as command. So those are all built into Windows. So for example, if I said run as, I could go and do that, right? And then if I wanted to run as something else, I would be prompted the same way. So it's configurable to a point, but I could also hold down Control and Shift, and I could go and run the terminal boop, as administrator. Now I have a lightning bolt to tell me that I'm an administrator, and I could go and do administrator type things. So that is on the Windows side. On the Ubuntu side, then yeah, it works like it is Ubuntu. It is a full Ubuntu. Windows subsystem for Linux includes a Linux kernel, works just great, and it would let you run as any user, and you can create other users and do all kinds of fun stuff. So that's cool. Now, over here, we determined that we are doing .NET in Windows, and over here, we're doing the exact same bit of work, except we're doing it in Linux. Now I'm going to close PowerShell and bring Ubuntu here. I'm also going to hit Alt-Enter. Alt-Enter. See how that's gone full screen? And then I'm hitting Control-Scroll to make things bigger and smaller. And I also want to point out my lovely background image down here. You can have background images. So for example, if I were to bring up the command prompt and PowerShell, I think I put my colorful one in that PowerShell. There we go. So now I've got in the lower right-hand corner, cool layouts to remind me that I'm on Ubuntu. I want my Ubuntu colors to look nice. Okay. Now, where are we? Right now we are on home scotthanselman.core. We are not on the Windows file system. The Windows file system, from the point of view of Ubuntu, is over here on C, Mount C. You can see, in fact, C, D, E, and F are all right there. So if I wanted to go over to the D drive on the Windows side, I am going to have to be a little conscious of what I'm doing. And this is the code that the Windows person was running. So how would I access that? I could type explorer.exe if I was running Windows, right? But I'm running Linux. But can I run Windows executables? I could run notepad.exe, can I? Let's see what happens. Well, I just ran from Linux a Windows executable, but because we're running the Windows subsystem for Linux, when Linux realizes it can't do anything about it, it passes that on to Windows, and that allows us to go and do some interesting things. Like I could say explorer.exe and then pass in dot, which is the current folder, And look at this. That's the GitHub, where's where I was, okay? Let's back out of there. Let's go back home. So we'll put in the tilde, and we'll go back home to the Linux version of my Hanselman.com. I'm going to say explorer.exe. I'm going to hit enter. Look at this. They have set up a mini network, what's called it is unexpected. I love that you said that. Thank you. Someone in the chat just said that was unexpected. Look at this. So check this out. I'm going to go and say snap, and then I'm going to go and say, where did my terminal go? Snap, 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 snap. There we go. And let's open up Ubuntu and Kali Linux and W Linux, and then let me start Docker. Watch on the right-hand side. Any Linux file system is accessible from Windows or any Windows application. Okay? Are there Michael Kissin is saying, are there restrictions on stuff you couldn't do? Absolutely. You can't go and delete the Windows folder or do naughty things. So yes, all of the appropriate security bits are there, as are including group policy and other things of similar ilk. But the other thing I could do that's interesting is I could type this. Let's say I want to do, we've already proven that I could do a .NET build, so a Linux build. Let's say code, period, dot meaning the current folder. Look at that. Look. Updating VS Code server. VS Code server? I didn't ask for that. What's that? What's going on? What is happening? Look at this. Installing C# dependencies for Linux? We're inside of a Windows app. We're inside of Visual Studio Code. Look at that. Look at that. Successfully installed the .NET Core debugger. Okay. Look down here. We are talking to WSL. It knows we are. In Visual Studio Code, if I say file, open file, that is the Linux file system. That is the Linux file system. If I said show local, that is the Windows file system. So that's interesting. So this means that I could come down here and I could start typing, and am I going to get, look at that, I'm getting IntelliSense. Visual Studio has split in half. The Visual Studio Code server, where all of the extensions run, lives in Linux. The Visual Studio Code client runs in Windows as per usual. So when I hit dot and I pop up my IntelliSense right there, that list was populated from Linux, not Windows. All right. Look at the extensions. I can see my local installed extensions, and I have 6 extensions installed inside Linux. Those are running in Linux. So now I can hit F5, build on Linux from Windows, start up my application. I'm in a debugger now. go off and start doing my thing and potentially debug this, step through it, and go to town. And it will automatically forward the ports for me. Isn't that cool? Paul Breen's brain just exploded in the chat. I'm just going to bring that over here so we can see Paul's brain right here. Cool. So as I get to the end here, unless we have some questions or a Paul or someone from one of our friends is going to jump in and tell us how much time I have, because I don't want to take away time. After me, we've got Andrea talking about the history of .NET. We've got Alan talking about serverless and Azure functions. And we've got Laura talking about her graduate project. So there's a lot of great stuff. So I want you to make sure that you all stick around. And folks will jump in and let me know how we're doing on time. Ross Jenkins has a lovely question here. Does Linux know that it is virtualized? It does not. There are ways to poke around and ask, but it is not aware. How does it know to hand over to the parent OS? So if I said notepad.exe, what we have is a custom Linux kernel. So if you go and search for WSL GitHub, we have the WSL2 Linux kernel. In here are the bits where you pass off. That's if there's anything aware of what's going on, it's this fork of the Linux kernel that then allows those handoffs. That's a great question from Ross Jenkins. All of that source. It's a very stable kernel, though. We're not doing anything wacky there. This is actually an LTS version of the kernel. So you can also build your own kernel, by the way. That's another important thing. If you're a hacker and you want to be doing something cool, you could make a custom kernel, and that's actually totally cool. And knock yourself out. It's great. Like, custom kernel, it's your computer, do what makes you happy. It's totally cool. Great question here. NRG is asking, how's my RAM doing? Awesome question. So this is good. Now, remember, I started up 6 different Linuxes. So notice this VM mem right now, it's about 6 gigs rather. So let's do this. I'm going to pop that over to the side. I'll pop this over to the side, and we'll open up PowerShell. And let's go and run WSL. Mark Allen is asking how I'm drawing on the screen. I am somewhat competent at using Zoom It. That does not actually say Zoom It. Zoom It from sysinternals. And there's different commands. So you hit Control-1, then you hit Control-Shift and pull back. That's an arrow. I can also change colors. I can draw boxes, and then just generally be a teacher in real time, which is kind of cool. Then I hit Escape to leave. Now, I want to point this out. We've got 1, 2, 3 different of these running, okay? But if I go down here and look at the WSL command, because the question was about RAM, there's 2 things we can do. First, I can go and make settings changes to reclaim my WSL RAM. So say WSL reclaim memory. There's a whole discussion about memory reclaiming. Okay, we can actually go through this on each one of these, and there's a little command you can do where I could say, drop caches as the root user. I could do that. We could shut it down, and I could go and say compact memory. So there's a couple of different things that we can do if I were to drop out over to here. Actually, I need to sudo that. Why can't I sudo here? I'll do it later. But over here, if I said WSL-T, when I'm done with the thing that I'm working on, I can terminate those, or I can actually just shut down the whole thing. See right here, see the memory? Now it's down to here. Additionally, there is WSL conf from memory, and you can set a memory limit. So if you have any memory concerns, you can actually manage these individually, which is totally cool and totally up to you. All right? Cool. To my friends who are running Bash with me, who are having a chat here, let me know if I'm doing okay, and if you want me to continue, or if you want me to stop, or if we have any other questions that we want to cover here, because I know that I'm doing about 5 hours in about 30 minutes here. One point here. Ioba1 is saying, is it possible to access COM devices from WSL? Yes and no. So if we go WSL-list-v, we see that there is one default version here, which is version 2. That's got a little star there. It's my default. WSL1 allows access from the COM port. So WSL1 allows COM port access. It is slow on the Linux file system. WSL2, no COM port yet. Slow on the Windows file system. And 10x faster on the Linux side. And I actually have a blog post that I showed a little bit earlier, and I'll do it again. We're typing WSL1 COM ports, and I actually walk through setting up a COM port to talk with WSL1. So if you're interested in doing Linux-based IoT devices, you can absolutely and happily do that with WSL1. And you'll notice that I have multiple WSLs of varying flavors, so I can mix and match them. It's totally okay to do that. That is a great question. All right. Cool. A lot of cool stuff happening. It is really a lovely time to be a developer on Windows because we can really do anything we want to. And who would have thought that I could go on Windows and I could go full screen and I could run Ubuntu and I could go and run, Emacs, and it would actually run. In this case here, I ran this version of Emacs. But if I wanted to go and run something at the command line, I can do that as well. So pretty cool stuff happening. And last but not least, so now I have to shut the whole computer down because I don't know how to get out of Vim. I can type Docker images and run Kubernetes. So I've got Docker images here in Ubuntu. And then if I go back over to PowerShell and I write Docker images, we actually share the same Docker. Look at that. Ubuntu, Windows. And what's exciting about that is that I could go back over to my D drive where we were doing our work before. I could take one of my applications like this one, and I could go and say Docker build. So I could go here, and I'm actually going to be using, there you go, look at that. I just built that and ran it on Docker. And that is happening inside of the context of the utility virtual machine. And I also want to point out that you can use WSL2 on Windows Home. So you don't have to have a pro version of that. Michael Kisson saying, will WSL1 ever be deprecated? It should not be deprecated until you can do everything you can do on any of them. So we won't take it away because it does useful stuff today. If there becomes a great way to do COM ports in WSL2 or whatever, then we would go in and do it over there. All right, I think I'm trying to eat into other people's times. If Ryan or someone would pop it, Garth, there you are. You're muted, sir. You are muted, sir.
I have it now. Yes, very good. So you have a few minutes left. If there's anything else you'd like to finish off on, or if you think that's it.
Well, I want to make sure that I respect everyone's time because we have such great speakers today. The whole bash is lots of people who aren't me. I do want to take a brief moment and advertise my podcast. It's called the Hansel Minutes Podcast. I've done over 766 episodes over the last 15 years. And it's worth pointing out that it is a lovely group of people and fresh faces on fresh technologies that you might not hear. And it goes on forever. So you can really just keep scrolling and see amazing people talking about amazing tech. Do check that out. And also, if you take a look at computer stuff they didn't teach you.com, computer stuff they didn't teach you, or just go to YouTube and search for me. I have a YouTube channel now, and I'm feeling pretty positive about it. And I talk about things like this, computer stuff they did not teach you in school. And I just got my verification check after 14 years on YouTube just yesterday. So I'm very excited about that.
I was going to say, I used to have a client in Galway that I would go and visit about once a month. And that's where I would catch up on Hansel minutes. So I would measure the drive to Galway in terms of Hansel minutes. So that 6 Hansel minutes trip, So
the show is 30 minutes long, so it's a great thing, like a Pomodoro. You go for a nice brisk walk and you bang out a Hansel minutes, And another thing I wanted to show that you might get a kick out of, and you might like this, Garth. Check this out. I now have searchable transcripts going back to the entire archive of the show. So I can go in here and I could find, I don't know, Africa, and it'll go through 700, 600, 766 episodes and find these things. Look at that. And then you can click on it, right? And then you'll go directly to that text and it'll start playing it. And you can then click and it'll walk you through it. So it's great for people who are either learning a language or are learning a new language. So I'm very proud of the transcripts working out right now.
That is absolutely brilliant. So let me just say thank you so much for an awesome talk. I know I was supposed to be dropping in with questions, but I was just drinking that in. I mean, that was all absolutely amazing. And I think we've had more spontaneous questions in the chat than any previous Bash talk. So absolutely excellent. Thank you so much indeed.
Brilliant. Thank you for having me. I'm excited to be as part of such a great lineup of folks.
Cool, very good. But now I must dismiss you. So Ryan, if you can please vanish, Scott. There we are. And I can assure everybody I have just gone through the most holy ritual of our profession. I have turned everything off and then back on again. So hopefully I'm back for the rest of the event. So sorry about that at the beginning. So we had my machine was doing an update, the network crashed and the bulbs in my light went. So we're now in a reserve of all three, but hopefully everything will be fine. So if we can bring in our second talk. So if we can bring in Andrea, please. Yay, how are you?
Hello. Great, and you?
Yep, good now, good now. Yeah. Do you have your cat?
No, he escaped. He had to go on an important meeting. Cats and meetings, the business stuff.
But very, very important, yes.
Of course,
I can always bring mine back just by rattling the dreamies, and that usually works,
Yep, that's totally the thing.
Yeah. Would you like to describe, I know that your talk is videoed and we're going to play it in just a minute, but would you like to introduce it first of all?
Sure thing. So this talk is a little bit about .NET history. So it's not like, oh, this is exactly what happens, but it's just some key aspects of things that enable .NET to happen, and also some other things that are about the .NET framework itself, and some things about the language, and kind of wrapping it up. This talk could really be probably 2 hours, but I trim it down to half an hour. So if anyone has any particular topic they think I've missed, I'd love to hear about it, but also, time constraints, etc. One other thing that is important is that I just tweeted all the resources that I used to make this talk possible. So it's a selection of videos, papers, blog posts, etc., where my information comes from, so that people can, if they're interested, they can dig deeper.
Yes, and I think we're either just about to, or we just did RT that on the Dev Bash account, and we'll put the tweet in the chat as well. Very good. So just to say that you'll be available in the chat anyway to answer questions whilst the video is playing. So Ryan, if you can please dismiss us and just play the video.
Today, we're going to talk about the history of .NET and its languages. My name is Andrea Magnorsky, and if you're watching this talk and want to do any comments or questions, please contact me via Twitter @silverspoon. To ease the understanding of how this talk would flow, I created this probably kind of contrived diagram where you can see 3 main tracks. There is a track about Microsoft, where we will talk a little bit about the company and its origins, and winding up in the creation of .NET and the different programming languages, which is kind of the main focus of our talk. Then also we'll be dealing with or looking at the history of virtual machines via BCPL and UCSD Pascal and their beginnings of virtual machines. And also we'll be looking at the ML family of programming languages, which wind up heavily influencing F#, and the people involved in F#, which also heavily influenced .NET. Right. An important disclaimer when we're dealing with history and history of programming languages in particular is that, maybe things look like they're ordered and clear. However, they rarely are. Also, you need to be prepared to maybe that thing that you're holding on and hoping that I would mention, that it is not mentioned. Anyway, without any further disclaimers, I will move on to our next slide, which is really the beginning of the talks. So this is a little introduction about Microsoft, the company. So it was founded in 1975, and infamously, it started off with the implementation of one of the implementations of BASIC. So there was our basics before. The Microsoft mantra at the time, if you want to call it that, is they wanted to do software across machines, and they were really about trying to help the developer with tooling and create a good set of tooling that was accessible across multiple machines. They obviously wind up becoming the company we know, as in they develop operating systems and such. And an interesting bit of information, since the conference is based in Belfast, is that Microsoft came to Ireland in 1985. So that's that about Microsoft, with a little bit of where the company comes from, etc. Now, the next thing we're going to talk about is the family of languages known as ML, or meta language. So the background of this programming language is that it was created by people as a tool to help them solve a complex domain, such as theorem proving and constraint solving. What you see here on the screen is a little bit of early ML. And let's see, if we look at this little sample, what can we derive? What did the language do? So one of the things we can see here is the language supported pair matching and recursion, since it's calling itself. It supports exception handling, all the OR constructs. One of the things that might not be very obvious is that it has quite interesting type inference implementation. So by type inference in here, we mean that the compiler would complain if something doesn't make sense. Obviously, that's a simplification. But for example, if n was a string, this probably wouldn't work. So maybe it is interesting to understand why that wouldn't work. So we'll look at that in a second. But another things that we might not see here, and that I will just tell you about the features of this programming language, is that it had generics, or parametric polymorphism. This was pretty new at the time. In fact, it was first seen here, and more or less at the same time also seen in CLU, the programming language by Barbara Leskov and her team. Another thing that you might not know that is here is that this is a statically typed language with garbage collection and first-class functions. First-class functions means that you can pass a function as a parameter to another function. All right, so I mentioned very briefly that this type inference. Now, there is many types of type inference, just to make things more complicated, but this is just the one that we're showing in this case. And it's interesting to understand a little bit about how it works. So what we see here is a small sample of F# code. So in this piece of code, basically it's a function definition for a function called myFunction, the same as there, with an argument. The function starts with an if, and the if has 3 parts. As we see, this is an AST representation of that same code. So this is just easier to follow this way. So an if obviously has 3 parts: the condition, the true part, and the false part. So in this AST, abstract syntax tree, we have the argument. This is the same thing. So it's the same node that we're pointing at. We have the if, as we mentioned before, with the equal and the result for the true or the false set. So what does the compiler do here that is so interesting? Well, it's saying, I want to try to understand, based on the information I have, what are the values that I don't know. In this case, the compiler doesn't have any information about what kind of type is an arg. And also it doesn't know so far, it's not written anywhere, what is the result of this function. So if we start here to try to find out the arg, or the argument, the compiler is going to know, okay, this operation, this expression needs to reduce to a Boolean, because that's what I want here. And so to make that possible, this argument definitely needs to be an int. And if this was a function, then the function will have to return an int. So the compiler deduces that arg is an int. Now, when it comes to the result, it is easy to see that both of these are ints. And so it knows that. But say, for example, this was a variable, then it would say that that variable or value would be also an int, because 20 is an int. Now, the reason I'm explaining the Hindley-Milner type inference, which is its known name, is because I wanted to tell you a little bit about where that comes from. This type of thing, this type of procedure is called unification. And this is something common in logic. And if you think about who invented this or who came up with ML, which is people that did theorem proving and constraint solving, this seemed like a really natural solution to the problem of how do we do type inference so that our programs are a little bit more correct. Now, this is just one of the type inferences, and there are others, and we'll actually see some different ones later. So we're going to move now to virtual machines. When we discuss virtual machines in the context of this talk, we're talking about process virtual machines. And they provide a platform-independent programming environment that basically abstracts away all details of underlying hardware or maybe operating systems. And this lets the program execute in the same way or in a very similar way in any platforms. These are machines in the true sense, as in they have an instruction set, processor, memory, right? So they have access to using these things. So how did they get started? Well, the story of where we're going to pick it up anyway is going to get on VCPL. So VCPL is a programming language from the second part of the 60s. And VCPL is a predecessor to B, the programming language, who is in itself a predecessor to C, the programming language. And VCPL used macros to generate O code. So O code basically was the platform dependent aspect of the compiler, where the VCPL had also another part that wasn't dependent, right? So they generally use the parser and the lexer as completely independent parts of the compilers. And then when they had to implement the rest of the compiler for a given machine, they would go and do it. Now, subsequent to that, there was an advancement on the virtual machines technology, especially on UCSD Pascal, using a thing called P code, which now there's something very interesting about P code, which is that James Gosling worked on the implementation of one of the P codes for one of the programming languages that implemented it. P code is more of an idea than a concrete machine. So James Gosling is someone that we'll be talking about soon again. If we're also talking about virtual machines, we definitely need to mention set machine. So around the second part of the 70s, there was a game called Sorg. And this game was very, very, very popular. And it was created by a company called Infocom. And they developed this virtual machine, and it had some interesting advances. So if you're interested in learning more about virtual machines, these are three, and its history, obviously, these are three that you should probably check out. Right. So we talked about UCSD Pascal, and we mentioned James Gosling. Between the 80s and 90s, something happened. And that something that happened is that the programs that people needed became more and more complex. The personal computer was a reality, and more people had access to not only personal computers for business, but also for leisure. So as programs became more complex, the imperative weight of writing programs was just not enough. And people needed better abstractions. And what came out at the time was object-oriented software. So this is when we think about who was using, the beginning of object-oriented software. We're talking about like Smalltalk. We're thinking about C++ and its implementation of object orientation, and what was mainstream was mostly C++ with a lot of more languages in the periphery. And in the middle of all that, like in the first half of the 90s, James Gosling and his team at Sun Microsystems developed the JVM and Java. Now, this was a groundbreaking thing for a series of reasons. If we think about the way that people evaluated languages at and around that time, which is like the first half of the 90s, mainly they were asking two questions. Does it support inheritance? And is everything an object? So Java kind of landed in a perfect place there. But what was Java at that time when it was released in 1996? Well, it was object-oriented and modern. It has write once, run anywhere. And that basically got rid of any dependence on a particular operating system. I don't know if you were around at the time or if you remember, but in 1996, the most popular operating system in the world was definitely Windows. And so, but there were other operating systems, and obviously Unix and Linux were available and still there, but definitely the cutting edge there was for Windows. And having the ability to have operating system independence was a very powerful feature. The other thing that Java had at the time of this is a very early web. It had the capability of delivering end user applications via the browser. This was pretty groundbreaking. It also had a set of technical devices such as a virtual machine, we will talk about it a little bit, and a garbage collection and garbage collection. So remember, or maybe I'm not saying remember because I don't actually know if you remember, but at the time, if you used a language with garbage collection, you weren't a real programmer, trademark, and I'm doing air quotes as well. It's funny that because in reality, well, as we saw before, and I mentioned that when I was showing ML, that language in the 70s also had garbage collection. And trust me, the people doing, theorem proving that they are definitely real programmers. But, that's what the programming culture at the time was. And today we have something else that is equally silly. But so when this came out, it wasn't maybe for real programmers, but it was extremely efficient and people were very interested in that. Another thing that is interesting to note is because the Java was a true contribution to applied academic computer science. This basically made Java the de facto standard for typed object orientation. And interestingly, and since we're talking about .NET, it was developed by a rival on the upper end of the operating system market. So basically, this created a big problem for Microsoft, and well, we have to wonder what they did next. And so initially, Microsoft actually embraced Java. In fact, they delivered something called J++, and it was pretty successful. However, for a series of legal problems and other things that you should probably totally check out if you're interested, they decided to react to it. And to react to it, they decided to basically create a project. And this project was internally known as Lightning, which wound up being called .NET. But Lightning wasn't supposed to just react to Java, but also it needed to address a problem that Windows had since the beginning, which is how to deal with it programmatically. Like, what is the programmability of Windows? Before that, it was called COM, and it was, well, painful. But so with Lightning, there was some founding principles, right? So the founding principles is that they would support multiple programming languages, and it include the commercial ones such as BASIC, C++, and Java, as well as some academic languages such as Haskell. Yes, you heard properly, Haskell. There is an implementation of that. AFL, Mercury, Standard ML. So we hear ML again. OCaml, which is actually also on the ML family, and Scheme, which is programming language in the family of Lisps. There was also a new language that it started off being called Cool, and it was developed by a team it was designed by the Anders Helsberg, which at the time was known by Delphi, but maybe now you also know him by his work in TypeScript. It supported garbage collection, JIT, and or middleware features like security and remoting, do application development on Windows, and the SDK would be free. Now, this is a key thing that they were really going for. And this is also kind of aligned with what was happening with Java, which I mentioned before. They also were trying to be working with academia, right? So SDK being free, main thing of doing efforts on academic relations. Another thing they did for academic relations was to found Microsoft Research. So they started off in 1992, and this is an extract from a paper by Don Syme called Early History of F#, which is a thrilling read, and you should have a look at it. But in here you can see who were involved in early Microsoft Research. We're talking about Andy Gordon, very young researcher in PL. Luca Cardelli, who implemented one of the implementations of ML that was quite successful. Simon Peyton Jones, which is the main Haskell designer type thing. Still Tony Hoare, I think we all know him. And finally, Don Syme. Well, there's other people, obviously, but Don Syme is one of the people that worked on .NET itself. And we'll see soon that he also worked in the generics implementation of .NET. And also, he's the designer of F#. So the collaboration between all these academic people at such an early stage of the development of .NET had some important side effects. And the first one of that I can recall right now is the addition of tail calls in as an instruction set in .NET in the bytecode. And also they started raising the question of language interoperability, meaning how should languages in the same platform interact with each other? Should there be two garbage collectors, one for the language and one for the runtime, or should there just be one and then the runtime would manage the garbage collection for the language? And also, what are the side effects of that? And also, what does it mean on how does it limit which languages and how are they going to be implemented, which are all very interesting questions. So if we're thinking about that, one of the key differentiator between .NET and the JVM is the generics and how they're implemented. Well, not the generics, but it's generics and how they're implemented. So given the audience for this talk, I'm going to assume that you more or less have some idea what generics mean. But just in case, I added this example here on what would some code without generics look like, and then some code with generics. This is from a paper with this name by Andrew Kennedy and Don Syme, where they explain how generics work on .NET. So the main advantage of this for the user is that if you don't have to this has type information, so you can pass something and assume something being like this is a type. So if you have a string or your own type or whatever, this will work. And the compiler will verify that that's the case and is consistent with itself, which is very useful. So since we can't really know why they decided on one or the other, as in, should the compiler, so should .NET keep information about the type in the runtime, or maybe it should erase it and just assume that it's fine. The compiler will compile and verify that all is good at that point, but then lose it and you have to deal with it or not. One thing that we can deal with is understand what were the guiding principles when it came to implementing generics. So some of those principles are orthogonality with respect to the existing CLR. So what that means is when possible, the generic type instantiations, they can happen in any context when CLR types may occur. Note there that we said CLR types. Another thing that was a guiding principle for the generics is that it should be language independent. So it makes no assumptions about what the source language is. So there's no, oh, this needs to be a C# type. This is a no assumptions. And the design of the generics need to allow for extensions for languages that don't have generics in that time. And this is especially important for languages like BASIC and C++, and obviously C#, since at the time before they were added to the runtime, it didn't have any. It also needed to have implementation dependence, as in the runtime compiler needs to be free to expand the generic type instantiation in a way that it sees fit. It needs to be efficient. And this was actually something that was really hammered at the time. So something at the time that it went out and all the PR went to like normal people that are not programming language designers. So what that means is the design of these generics needs to be so that if you write code using generics, or you write the same code or equivalent code not using generics, both implementations need to be equivalent, or the generic one needs to be faster. And another really important one is that it needed to be statically checked at the point of definition, not of use. Otherwise, it kind of becomes a lot less useful. Still useful, but not as useful. So these were the tenets with which generics were designed. .NET Generics was released in 2005, and it's been 15 years. And what we can say is that they have been hugely successful. It's been adopted by millions of programmers, both C# and F#, and it's a key differentiator between C# and Java. It also allowed for many innovations that were delivered later in F# and C#. For example, generic collections, link, tasks, async await, span, and obviously F#. So one other thing that is really interesting when it comes to .NET is that there is, its main language is C#. And in C# there is this feature that was released in C# 3 called link. And what this feature does is that it allows you to abstract over any data model. Initially, it supported objects, XML, and relational data, as in data coming from a database. But it was really interesting because it made people think about this in a different way. Basically, it wanted to remove the impedance mismatch between trying to write code in your C# code, and you're like boop, 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 boop. And then you have to go to the database and you have to write SQL, and then you have to do something else to get XML in. And so what I was trying to do is like, okay, you already know how to C#, so just stay in this thing, and then you have less things to think about. This was only possible because, for example, in here we can see there's some type inference. Now, this type inference is different to the other one we saw earlier. This is local type inference. And, if you want to read about type inference, that's a huge rabbit hole that I totally recommend you to fall in. But in here we see a little bit, and that basically this little bit of type inference makes possible that this expression here looks a lot nicer, because it would be a lot more cluttered if it wasn't the case. And this also looks very different to the rest of C#. This looks very expression-y, mainly maybe reminding you a little bit to the ML we saw before, or maybe a little bit of Haskell, which is kind of where the inspiration for this comes from. Now, and this since we're talking about programming languages in .NET, it is, well, it would be a huge miss to not mention F#. So in here, I'm showing you some F#. As I mentioned before when I was talking about ML, the main reason for the tool was to try to wrangle in a complex domain. And actually, even though F# might be known to some people as something that is only for maths people or very financially or whatever, it is a great tool to deal with complex domains that appear in any industry. So much so that there is a very, very popular book called Domain Modeling Made Functional, which I also recommend you to check. And I was also trying to make a point about how much F# is about that. So let's see what is going on here in F#, in this F# code, and maybe we can compare it with how that ML code that I showed you at the very start of this talk, how do they differ, right? So in here, the code should be equivalent. And here we still have some pattern matching. Maybe it is a little bit nicer to read. We also have exception handling. We also have the type inference in the case of F#. I'm using, and here is a screen grab of me using it in Visual Studio Code with Ionite plugin, and I was running on Linux without any issues. So, the plugin actually tells me what the type signature of this function is as we're going, which is super helpful. In F#, unlike in ML, you do need to tell the compiler that we're okay with recursive calls, and then, well, conditionals, whatever. It's a very, very similar language, and except with like go fast strips that come by the fact that F# is a .NET language, and that means that all libraries and ecosystem, it's already there, and you don't have to, create all of that with it. So I think this brings you very much to the end. We went over some of the tools that made .NET possible and some of the key features of the platform and the language. As time elapses, it is easy to see that from a language point of view, there has been a lot of progress. Kind of like this, maybe, person. But also, it seems like maybe sometimes we've gone chasing our tails. Either way, learning history and trying to understand the context of some of the solution is bound to yield great results. And with that, I want to thank you for being here. And I want to also especially thank all the people mentioned here for helping me make this talk a reality. And also, I wonder if you have any questions. Thank you very much.
Excellent. Thank you so much for that. Few follow-up questions here just before we let you go.
All right.
So first of all, do you think the ML lineage is finally getting the respect it deserves? Because for a long time, if you went up to people and said ML, they'd have gone, what? But these days, everybody seems to have heard of it from many different directions. I mean, as you say, maybe they've heard it through F# or a Scala talk, or maybe they've heard of Reason ML or something more esoteric. So do you think it's finally getting the respect?
I think the main thing about the ML family of languages is really the domain modeling. And because that's a problem we really are trying to solve now, either because of concurrency and parallelism or because we just have really complex domains. I think it's just leaking through because it's a solution we have to this problem.
Yeah.
So yeah, and also like people love it. The reaction to people is generally you love it or hate it. but but I think people that feel like it really allows them to express themselves in programming, they really are a fan. You become a fan, and you're like, I want this. I want to bring this experience to my language, and so you can see it now slowly leaking through Scala. Like in Scala 3 is a lot more ML-y than it was, even though it was quite ML-y already if you were squinting and wearing the correct glasses and such.
Yeah. Cool. Very good. And I think it's part of the idea that, nothing in IT is ever really new. We've all had this before. It's like for certain ideas, the time is just right, and it just emerges,
Yeah. In fact, this is what I'm trying to say with this talk is like studying a little bit of history, even though it sounds like really boring. A is really good if you're getting old because it actually just fits in naturally with you. But but also it's really important because suddenly all these new things appear a lot less scary because you start to understand where they come from. So it's totally worth it. And any rabbit hole you're interested in, there's some person in the 1970 something that did something, or maybe even before the maths people did it 200 years ago. and you're like, oh, I thought I was being really smart, but actually this other person did it and they did it better. Okay, I'm going to grab my coat now. Anyone for a point?
Another one from the list here. Do you think that now that C# is becoming more declarative, will that prevent F# from growing in popularity?
I asked a very similar question to Edwin Brady, the guy that made Idris and Brain Freak, and I said, similar question, and he said something that I think really answered your question, and he said, what we want with programming languages is that the good things filter through eventually to the programming languages that everyone uses. So I think I really like that. If people are using these tools for thinking, then great. If it helps, like the link was massively like that. I remember people were very uncomfortable initially. We were there, right, Garth? Oh yeah. And people initially were like, some people instantly got on with it, and but other people were like, I hate this. I absolutely hate this because it was very unfamiliar, whatever. But it's a thing that kind of slowly filters through, and it needs to kind of come in a nice coat. Maybe it's like 3 sheep with a trench coat, and it's like, ta-da!
Yep. No, that's a wonderful answer. And I met Edwin once at a conference a few years ago, and that's so typical of him because he's such a nice guy, that as long as developers get what they need, it's all good. I mean, if I was him, I'd be running out for my Idris book deal and trying to get my conference talks and, trying to monetize everything as much as I could. But he's a really nice guy.
Yeah, I think, he's you should get him on one of these bashes. He loves Ireland. So he's a very big fan. That's why anytime I invited him to anything, he was like, yeah, I'm there.
Yeah, he's actually on the list. We keep trying to tempt him away from Harriet Watt, but it's a long way to travel. But definitely for a virtual bash, we shall try and get him over, definitely. One last question, I think, because we're almost out of time. Just to put you on the spot a little bit, with Link, whenever they introduced Link, it was billed as a universal query language.
Yeah.
Do you think, were they really trying to do a universal query language, or was that kind of the excuse to sneak FP, into .NET? So what do you think?
I mean, when I was researching this talk, I actually found an interview with Eric Meyer that was basically unashamedly admitting both. So it's not what I think, it's what I read. I think it was good. I think it's good having that, being able to realize that something is really useful. There's no better way than convince someone to try something like, oh, okay, this is really useful for that. So especially people that are programming, because we all have like problems. It's not like, I hate doing that thing that is complicated and awkward for no reason. So if you get a nice solution, you're like, oh, could I use the same idea for something else?
Yes.
Yeah. So yes to both. And yeah.
Excellent, but very good and also very diplomatic. Excellent. So, so time marches on. So I must dismiss you. So thank you so much for your contribution.
Yeah.
And Alan, if I can call you up. So cool. So if you just want to introduce yourself and what your talk's going to be about, and then I shall vanish.
Sure. I'm Alan Turpin. I work at ESO, and today I'm going to be talking about the lessons I learned about Microsoft Serverless, specifically Azure function apps, and the reason we chose to use them for our microservice architecture.
Excellent. Very good. The floor is yours. I shall vanish. Yeah.
Excellent. So let's get started. So at ESO, we're all about improving community health and safety through the power of data. Our main products are all about making first responders' lives easier and making sure they have all the necessary data that they need to determine outcomes for patients and the likes. We have applications that help track medication right the way to scheduling people and equipment to be in the right places at the right time. So that's a bit of history about our company. So the story I'm going to talk about today is a common one that many software developers will come across. When you inherit a monolith application and you've been asked to add a new feature. Monoliths are inherently unstable because you never know what small change you might make will break something or have an adverse side effect that you weren't expecting in some other part of the application. So as microservice architectures are being more adopted commonly, we had the unfortunate opportunity or fortunate opportunity, however you want to say it, to implement some Azure function apps to implement a new feature in our scheduling product. So let's talk about the journey. So our problem here was we had two different systems. We had the ESO main suite and we had this new scheduling project which we acquired. However, you don't want to have two separate logins to two systems that are all owned by the same company. You want one. So you want some form of single sign-on identity. And the way we do this is using an identity linkage service, which will basically allow you to log in with one, then log in with the other and say, right, there you go. Those two identities are now permanently linked. Adding this to a monolith application can be incredibly, incredibly difficult because you've got pages scattered throughout different projects. You've got APIs that interface with passwords and the likes, and it is a really, really tricky problem. So the way we came up with it was we decided to go down the route of having an Azure function app that would take the two unique identifiers and store them in a table storage. And then any time when we look up a query for a person, we could easily get the associated unique identifier for that person in either the scheduling product or the ESO suite. So an overview of why we chose Azure Functions would be a very, very long talk. But here's some points that I found whenever we were going through. I found that the application itself was very versatile. It is incredibly scalable depending on what you need it for and the usages and how many people are going to hit it. If you're going to be something that's small, it's a small tool, great, you can keep it nice and small. If it's going to be something that's going to be called 100 million times a day, you can scale it up to have multiple instances without massive problems. There's native security there. I'll talk a little bit about pricing, not too much because obviously that's going to vary depending on your circumstances. How to deploy a function app using Azure pipelines in a very nice, simple YAML structure, and some extensibility of the function apps. So the first thing I want to talk about is versatility. It supports a whole heap of languages. So it's C#, Java, Python, PowerShell. I know they've got F# coming in there soon, and a few others on the works as well. But it also supports our common package management platforms such as NPM and NuGet, which is really important whenever you're working on small projects. You don't want to have to, rewrite a PDF export or some form of common code that you can get from a NuGet package. You just want to be able to dump that in there and call the library. and it does that so beautifully. It's exactly the same as you would any other C# project. The other thing then is the types of functions that can be called. So you might just have a HTTP request, standard API call. You're going to do a get, a put, a post, whatever. It supports that, but it also supports things like timer functions for cron jobs. So you can actually set it up to run, any standard cron syntax, and you can get the function to call itself at those time periods. It does other functions which I haven't actually explored yet, such as Cosmo database triggers, blob storage, queue storage, event grid, and the likes. All those you can trigger a function on a change or an event on one of those services. Next, we'll go into scalability. So scalability was very important in our context because to begin with, we're going to actually ramp this up as a single problem for this here identity linkage service, which could very well only be called, maybe a couple of 100,000 times a day. So we'd have maybe 1 or 2 instances of the function app to do that. However, as we grow more and more into this microservice architecture, we're going to need more functions. We're going to need more scalability. When we add our common pages like the scheduler worksheet, which is basically our main page, it shows the schedule of the employees and the ambulances. And it's like that could get called more than 1 million times in a day. And it has significant SQL calls in it. You need to have the scalability. Unfortunately, there's some really, really nice scalability rules in Azure Functions. So you can actually set up scaling rules based on CPU usage, RAM usage, even I/O settings. So if you're getting so many calls, you can say, right, spin up another function, and it'll just create another instance of that function, and then it will scale down when it's required as well. Some really, really nice scalability features in there. And because that's all done sort of natively through the Azure Azure Function app itself, you're not having to worry about setting up your own alerts or anything like that there. You just set up the roles, and then you can monitor all your usages using application insights in the Azure portal, which is really nice. Next, we'll go on to security. So security in the Azure Function apps is natively supplied by an API key. So you can actually set up each function in your function app to have either anonymous function or admin requirements. So what this means is you can apply an X function key header and say, right, this is the key I have. And if it's a function key and the function requires an admin key, you'll get an unauthorized response of 403. But if you set it up for anonymous, anyone can access it as you like. On top of that, we've actually implemented a sort of a bearer token as well. So we obviously have to have authentication within our website. So whenever the user authenticates, we obviously create their token. We also pass that up and authenticate that in our function apps as well as a second level of security. And then we actually have a third level of security. You can actually put your Azure Function apps on a VPN as well. So you can restrict access to certain IP addresses or from certain sources. So it does allow for multiple levels of security. And then more importantly, you don't want a DDoS attack on one of your function apps causing you lots of money if you're using a specific plan that's priced on number of hits, because that would be very, very bad. There are other security options which I've never actually dove into yet, such as OAuth that I am aware of that they support. I believe the Facebook and Google and .NET are the three main OAuth providers they use. I think they've also started to use OAuth 2 as well. Pricing then. So pricing is obviously important when you're choosing a platform. You don't want to be choosing something that's going to cost you, substantial amounts of money. Fortunately, Microsoft came up with a really, really nice pricing plan. So you've got two sort of ways of doing it. You've got the standard premium app service plan where you pay for a number of cores, etc., etc. It's always running. There's no cold start. It's really good for scalability. But then you've got this consumption plan. So if you're doing like a really small function that's not going to be called that often, you can actually run it on this consumption plan up to 400 gigabits second of RAM usage, and 1 million executions each month for absolutely free, which is great for little dev projects or side projects that you're working on, or just proof of concepts. It's absolutely fantastic. There is a downside to the consumption plan. It does turn off after an activity, and it does have a cold start of about 15 seconds usually for your first call. Likewise, there are other restrictions on the consumption plan. You have a limited amount of time that a call can run for. I think it's 10 minutes at the current time. You may also have other restrictions due to the Azure load balancer, which I think actually times out a HTTP request at 3.8 minutes, if I remember rightly. But regardless, the pricing for the actual function app was fantastic, spot on for what we needed. Now, this is the bit that I actually really, really like, is the ability to do CI/CD with the function apps. So we currently use Bamboo and Octopus for building and publishing of our main website to a VM on using IIS. But that their approach has limitations. You know, if you want to add a new project or something to that, you can't build an independent branch plan. However, Azure Pipelines allows that. And I know some others do as well, but Azure Pipelines is phenomenal for a companion to go with your Azure function app. And I'm going to go into a bit of code here, so hopefully it's big enough you can all read it. So this is an example YAML file. It's broken up into multiple parts because it needs to be big enough to be seen. But basically, you can commit this with your source code, and pipelines will pick this up for you. So you basically set up some variables to do with like what's your subscription name that you have to configure in pipelines, which I'm not going to go into because it's got sensitive information in it. But basically, you select, you know, your subscription, the app name, the function app name that you're going to, the slot you're going to, and then we've actually got some version numbering to actually write the version number to our DLLs that the Azure function app's built up into. The next step then is actually just to set the name of the build to the version number. Next, you do a nice NuGet tool installer. Make sure we're using the right version of NuGet, because you don't want to end up using one that's on the pipeline build agent that isn't the right version for what you need. And then do a standard NuGet restore. And this obviously is quite nice because it actually lets you override the config as well. So if you've got, as is our case, we have some certain NuGet packages that are on a VPN. Our Azure pipeline agent doesn't actually have access to those directly. So what we can do is we can actually commit those NuGet packages to the source code and then override the config to say, actually, no, don't get those from that private repository, get them from this folder instead. As an intermediary, you can then actually build your own Azure pipeline agent on your VPN so that it will have access to those NuGet packages if need be. Next, we just do a standard .NET build and then a publish output with the assembly version. That there will build all our packages up and put them in a nice little folder ready for deployment, which is what this step here, that's the archive files @2, actually does. So it actually then takes all those zip files and pushes them up to your function app. The first two steps here are then obviously building our test project, unit test project, and running our unit test project to verify that all our tests pass before publishing occurs. And then the last one then, the last two there are actually the deployment. It's the archiving into a zip file and then deployment to your Azure function. Really nice, really clean. If we needed to add in another test step or another step for a branch, we just modify that YAML file on the branch, commit that to our Git repository, and then in the Azure Pipelines portal, you can actually go in and select, I want to build that branch. It pulls that YAML file from that branch and performs those steps. Really nice, really clean. The other really, really important thing that I find with the function apps is the ability for redundancy. When you do a deployment, and you find out, oh, something's gone out that shouldn't have gone out, or there's a bug that's critical and it's causing clients issues, we have this set up where we push our staging slot. And then when we do a release, we actually put that staging slot into another slot called last known good, and then swap last known good with production. So our production function app ends up being in this last known good slot that never gets overwritten until our next release. So if something drastic occurs and we have to roll back, we've got that. Just quick rollback, flip the switch, swap those function app slots. And the swapping of the function app slots is really, really fast. And it produces zero downtime for the client as well. It's not like it's taking the first one offline and putting the second one online. It actually changes the DNS address. So it just says any new requests go to this slot instead of the current slot. And the ones that are still being processed on the current slot finish without being terminated. Really nice, really clean solution. Last thing I want to talk about then is sort of durable functions. So this is an extension method for Azure Function Apps. And what this allows is taking what the Azure functions do and expanding it. It's exactly what it says. It's extending it to more features. Some of them are sort of like for function chaining, where you're triggering one function after another function after another function. And what you don't want to be doing is having your first function sitting costing you money while it's waiting for the result of the second function. And durable functions do this nice thing where you await the result of something. If it's not doing anything else, it's not awaiting any other, it's not actually processing anything else asynchronously, it will not cost you any money because it won't be executing anything, which is a nice feature to have when you're running in the consumption plan. It also allows you to do things like fan out, fan in whenever you can run 3 or 4 functions asynchronously and you're waiting for the result of one or more of those before returning a result. There are other things that I haven't used, such as human interaction and monitoring timer functions and execution times. But I'm sure at some point I'll be looking into implementing something along those lines. Now, that's a lot of information in a very short amount of time to do with Azure functions, but my personal opinion on them is they're fantastic. They're great. There's so much you can do with them in such a small enclosed space. They're great if you're doing microservice architecture. They aid in domain-driven design because you just keep, basically you have a function app that is basically, this is one domain, here's another domain, here's another domain, and then you break down your functions within each function app to say, right, this function is going to be all about this thing, this function is all about this thing. And it's phenomenal in terms of, if I was coming out of university now as a graduate and I was going straight into this, just like Laura's about to talk about, I would be super excited because it's making my life easier. I'm not having to worry about infrastructure of all these separate little microservices and having to publish and deploy all these separate services to an IIS or a web server. It's all done by Azure Functions. I know I sound a bit like a fanboy, probably because I am. I was just so impressed with these whenever I first started using them. And that's me. Thank you.
Very good. Thank you so much. Let me just ask you a couple of questions there. So
Sure.
Number one, the question everybody loves to hate. Yeah. What don't you like? So it's obviously working well for you, but what do you wish that you had or wish was there or causes you pain?
Oh, that's a tricky one. There's been a few, like, when you get into the nitty-gritty of it and you're actually developing this locally, Visual Studio provides a really nice runtime, so you can run the Azure Function app locally. It does storage emulation and everything. My main problem is debugging an instance that's actually pushed to the cloud is very slow. You're sitting there and you've got your breakpoint. It finally hits that breakpoint. You press F10 and you're waiting 5 seconds before it moves to the next line. It's super slow. So that's where you need to bring your logging in. You really need to heavily log. If you can log all that and push it to a common logging interface like Sumo Logic or something, or New Relic, it'll make your life significantly easier.
Yep, and that was actually my second question. That one of the things that worries people about this kind of architecture is that you're going to end up with a big cloud of services or functions, and you'll know that something is going wrong, but it's really hard to isolate the fault. So is that your experience, or does the logging take care of it, or?
The logging takes care of that. I mean, if you do your due diligence with your logging, it will certainly cover, exactly where it's going. And we obviously get our error reports in, and we get, the exact line number and everything, and exactly what's going wrong, the full stack trace if we need it. And then we can reproduce that issue or reproduce the call to see if we can replicate the exact issue, which is quite nice.
Cool. Very good. Excellent. Thank you so much. So I shall dismiss you at this point. And I shall welcome Laura, if you can come to the front. Yay.
Hello.
Cool. So do you want to just introduce yourself and a little bit about your talk? Because this is another video one. So we'll do the in-person introduction and then run the video.
Yeah, so I'm Laura. I've graduated from Jordanstown this past summer. So this is my first real job. So yeah, whenever I started, I did a grad project to kind of get myself stuck into how we do things in ESO. So I'm just going to cover a little bit of it. I pre-recorded mine because there's a puppy that is usually hanging around my shoulders. I was like, I'll never make it through. So I got a quiet moment when she was asleep the past few days. But she's missing now, so it could have been fine, but sure.
Yeah, I was actually watching, but backstage there when she was climbing all over you earlier, and I was thinking this is interesting, but yes, no, she's gone off stage, which is good. Yeah. Very good. So, Brian, if you can conceal us and run the video, please. Thanks.
Hi there, everyone. My name is Laura, and I'm a recent graduate from Ulster University at Jordanstown. I started with ESO at the start of September, and as part of my training, I completed a project with the other graduates and placement students to help learn my way around the software and technologies that we use here. Some were new to me and some were not, so I'm going to be covering a small part of the project in my presentation with you all today. So first, ESO's mission. It is to improve community health and safety through the power of data. So the full project that was taken on by all four of us when we started was to create the whole third-party API that you can see here. Along with an existing API, Instant Report, we now have two APIs. Both of them have multiple endpoints, but for this presentation, I'm going to just talk about two of them. We have two types of agencies, a normal agency whose data is stored in the agency database, and a third-party agency whose data is stored in the third-party database. We want them both to have the same experience and use the same endpoint to send in their requests. To allow this to happen for a third-party agency, we want the Instant Report endpoint to talk to the endpoint in the third-party API, which will then go to the third-party agency DB and bring back the information all the way back to the third-party agency. The technologies used in the project are as follows: Azure Functions, REST APIs, repository pattern and dependency injection, Postman, error handling, unit testing, logging with Sumo Logic, and Azure pipelines. I will be talking more about each of these throughout. Azure Functions allow us to have a serverless compute service without having to manage infrastructure. The functions are triggered by events that we add to our code, making it easy to process and react to events. We are able to use HTTP-based API endpoints, as well as having multi-level authentication to ensure our functions are only being accessed by the right people. By using REST APIs, we can have statelessness, where requests are self-contained. Separation of client and server, where implementation is kept separate. Error handling, where response codes are managed. Requests, where HTTP verbs retrieve or modify server data. Response bodies, where error details are included and in JSON format. And good security practices, where we have authentication. So on this slide, we are going to talk about the process that APIs need to go through to get their data back from the third-party API via the Instant Report API. The controller in the Instant Report API receives the incoming requests. It then asks to the service layer to do things. This is the layer that holds the business logic. The service is then going to ask the repository or the client to fetch the data. Which one it uses all depends on whether the agency is a third-party agency or not. If it was a normal agency, it would go to the repository and get the data. But we want to look at it as a third-party agency. And as you can see from the diagram, if it is a third-party agency, it uses the client to call the controller in the third-party API. It then goes all the way through the endpoint in the exact same way as before. The controller to the service, but this time it goes through the repository, which uses the entity framework to get the data back from the database. The data is then sent back through to the agency for the agency to see the results. Repository pattern is the separation between the actual database, queries, and other data access logic from the rest of the application. So in our case, we need to separate the data access logic from the controller layer. Dependency injection is a software design pattern. It reduces the hard-coded dependencies among your classes by injecting those dependencies at runtime. So let's look at the existing third-party endpoint that we want to hit. This was created earlier by myself and the other grad and placement students. Looking at this, we know that the URL to hit this has to include the vehicle name, the date and time, and the agency ID. Without these, this endpoint won't run. If these are missing, they will be caught in the error handling exception statements that will allow the agency to know what they have done wrong. The current method in the Instant Report API at the controller level does not need to be adapted. As we have discussed earlier, the controller asks the service layer to do things, and here we can see that it is asking the service to get the staffing service for incidents. So this is where we're going to make our first change. So now we look at the service layer, and what is in the yellow box is what we want to look at right now. Originally, this if statement did not exist. So what happens now is a check is done to see if the agency ID supplied by the agency exists as a single sign-on client, which is exclusive to normal agencies only. If the check for the single sign-on comes back with a value, then we know that the information it is looking for is in its own database and can continue as normal to get staffing for incidents. If this check comes back with a null or empty string, then we know that the client belongs to the third-party API. This allows the get staffing for third-party instance async method to be run. If this comes back with data, then we know that it is returned to the controller. If there are no results returned, then it throws an exception that states requests returned no results. Check all your details are correct. So this is a newly made private method that is also in the service layer. Multiple instances can be queried through the one request. So this method allows each instance to be queried individually. This may need to be modified in the future to make this faster, depending on how many instances are being queried at once. But for now, this method works well. So for each instant queried when the data is returned, it is added to a list to be returned when each instant is queried. This is the final layer in the API to get the results back. As we have used Azure functions, we can set environment variables for each function app. This is where we store the information for it to reach the third-party API. These could change at some stage, so this allows us to change these variables if needed without making any code changes. Once it has these variables, we can put everything together to make the request URL. That will match the third-party endpoint and include the agency ID, vehicle name, and the date for the instant search. The request is then sent through to retrieve the information from the third-party database. If data is returned, then it is returned as a list. If data is not returned, then it throws an exception to inform the agency that their ID may not be valid, and now data has not been returned from either of the databases. We have used Postman to test if the API works by sending the GET request to the endpoint URL. Postman also allows you to hit breakpoints when running it locally, which is great when you want to test out your code. This screenshot is showing a normal agency sending the request. This screenshot is showing a third-party agency sending the request. The main difference between the two, other than where they are stored, is the fact that a normal agency uses unit ID as a number and a third-party agency uses it as a word. We have implemented a lot of error handling to ensure that time is not wasted by going through all the code, by allowing an exit route when something comes back that is not what we want. It also allows pinpointing of the problem that has occurred. We now need to add unit tests to our new software to make sure that it is working as it should. For this, we are going to use mocking, so that just the controller, service, and client are being tested, and there are no dependencies on the database to do our unit tests. This is done by creating variables and then setting them as a substitute instance for each type. And here we can see these substitutes in use throughout the unit tests. We have created a mock for the SSO client to return an empty string, which, if you remember, is what allows us to enter the third-party if statement. And then we have the third-party client mocked to be able to return the details above for the first incident with engine 1, as if it had really went to the database with the request. And for the ambulance, we are mocking the request with these details. This is then able to be asserted to ensure that it is doing so correctly. To add logging to the code, we have used the ilog service. This allows us to see what is happening in each request that occurs. So now, if something goes wrong, we can see more detail about it. For example, you can see that we have a log whenever someone enters the endpoint, entering get staffing. We can see if there is an unhandled exception, and we can see when they leave the endpoint. Azure pipelines combine continuous integration and continuous delivery to constantly and consistently test and build your code and ship it to any target. This is done via YAML files that you create in your solution that tell the pipelines what to build, what to test, and what to publish. In the example above, we are looking at a build and test YAML file. This ensures that the solution can build and pass all of its tests before anything is published. It is a safety net. You can hit it against any branch. So if you're working on changes and want to ensure the pipeline will go green, you can try it against your branch. This is a YAML file used to publish the changes to your Azure Function apps and databases. No tests are included in this, as we already know that they pass in the previous run of the build and test pipeline. And that's it. Once you have used the publish YAML file, you have added the changes to the remote version of your code, and it is up and running. And that's it. I have learned an awful lot doing this project, and this was just one small piece of it. Since then, I've been able to create a production environment which allows the new API and the Instant Report API to be able to talk to each other in production. This project was a massive jump from the projects I was getting to do in uni. So while the code behind it all might be very simple, putting it all together with all the technologies that we had to use, which I had no experience in before, was a big learning experience. So like the title suggests, one small change for a software engineer, one big change for a graduate. Thank you for listening.
Excellent. Thank you so much.
She has appeared.
Popper! Always good to see a Popper, you know. So we have a cat, so allegedly I'm a cat person, but really I'm a Popper person. So, but Poppers forever. Yeah. So let me just ask a couple of questions. So first of all, the reverse of the question I asked before. So what was unexpectedly easy? Okay. So what did you go to this project absolutely dreading, but turned out to be a breeze?
It's a good question. I guess I had a lot of people that I was able to ask questions to, which is great. That's not always the case. So it was I think just having the support of people who know a lot more than me was great. Yeah.
Cool. Very good. And then, so speaking as somebody who's relatively new to the industry, in terms of, you know, your peer group and all the people you graduated with and so on, how many of them do you think went directly into cloud versus went for other technologies instead? So how many of your colleagues seem to be just straight into the cloud?
No idea. To be completely honest.
Yeah. Yeah, that's probably a bad question to ask during a lockdown on reflection. Yes.
Yeah, meeting up and chatting about work is a wee bit harder these days.
Yeah, no.
I have no idea.
Yep, fair enough. On second thoughts, I withdraw that question. That's a little bit unfair. Yeah. No, absolutely brilliant. Thank you so much indeed. Sadly, we're at time, so I must dismiss you. Yeah. And as this is my final speaking engagement for the year, I shall endeavor to get into the seasonal spirit. There we go. So just to finish off, if I can say thank you so much to all of our speakers at this event, of course, especially, but also at all the Bash events during the year. Yeah, and thank you to the rest of the organizing team, in particular to Ryan and Zara for all the work that they've done. If you have any ideas for Bash events in 2021, or you would like to speak, please definitely let us know. And it only remains to say, I hope you have a very merry and safe Christmas, and see you all in the new year. So thank you so much.